On behalf of Rovini College of Engineering and Technology, myself Justin Leo, Assistant Professor of Mechanical Engineering Department, I welcome you all for this Unconventional Machining Processes course. And the course code is ME8073 and it is a professional elective subject for the mechanical engineering students, Regulation 2017. So here in this video session, we'll be studying the first unit, that is Introduction and Mechanical Energy-Based Processes, in which we'll be studying about mechanical energy-based unconventional machining processes. So the main objective of studying this unconventional machining process is to learn about various unconventional machining processes and the various process parameters and the influence on performance and their application. So here in the first unit, Introduction and Mechanical Energy-Based Processes, we have the syllabus Unconventional Machining Process, its needs, classification, merits, demerits, and application. And in the mechanical energy-based processes, we'll be studying about abrasive jet machining, in which we will be studying water jet machining, abrasive water jet machining, ultrasonic machining, and the working principles and the equipments used, the process parameters, and its applications. So these are all the textbooks and the reference books for this unconventional machining processes course. So these are all the course outcomes. So the students, upon completion of this unconventional machining processes course, in the first unit, they will be able to explain the need for unconventional machining processes and its classification. And in unit 2, the students will be able to compare various thermal energy and electrical energy based unconventional machining processes. And upon completion of the third subject, the students will be able to summarize various chemical and electrochemical energy based unconventional machining processes. And in the fourth unit, the students will be able to explain various nano-abrasive based unconventional machining processes. And finally, in the fifth unit, the students will be able to distinguish various recent trends based unconventional machining processes. So mechanical energy based unconventional machining processes, you have almost 4 types, that is abrasive jet machining, water jet machining, abrasive water jet machining, and ultrasonic. So in this abrasive jet machining processes, it is one of the non-traditional machining processes, mostly used in machining of hardened metals. And in this process, a focused stream of abrasive particles forces to impinge on the workpiece at a high velocity. And these high velocity abrasive particles would remove the metal by brittle fracture or by erosion from the workpiece. And mechanical based processes, we'll be studying about the abrasive jet machining process in this video session. And the principle of abrasive jet machining, and in this the machining process works on the basic principle of abrasive erosion. So here you can see from the figure, high velocity abrasive particles is made to strike on a hard or brittle workpiece, and this would remove some metal at the striking surfaces. And this metal removal process takes place normally due to a brittle fracture of this metal, and also due to micro cutting by the abrasive particles. And this is the principal process of abrasive jet machining. And these are from this diagram you can note out the abrasive jet machining equipments. So these are all the following parts present in the abrasive jet machining. First is the gas supply instrument, and the second one is the filter, and third one is the pressure. So a pressure gauge, and you have the mixing chamber here, and you have the nozzle, and you'll be studying about the abrasive particles. So the first is the gas supply. So a high velocity jet of air like nitrogen, carbon dioxide, etc. are enclosed abrasive particles is aimed at the workpiece, which would be under a pressure of 2 to 8 kilopascals. And you have a filter. You can see here you have a filter, and this is used for cleaning the fuel supply. And if any dirt or other impurities may not hamper the progress of the process. And you have the pressure gauge, the pressure regulator. So it is used to control the pressure of the compressed used in the abrasive jet machining, as the pressure decides the depth of the cutting and the amount of force required for cutting. So the pressure gauge is very, very important here. And you have a mixing chamber, and this mixing chamber, you have this abrasive powder is being fed, and with the help of a vibrator, amount of abrasive can be controlled, so that the abrasive and the gases will be mixed thoroughly in the mixing chamber. So next is the cutting nozzle. You have here the cutting nozzle. To direct the abrasive particles on the workpiece, cutting nozzles are used, and they are mostly made of tungsten carbide, and they may be available in both circular and square cross section, and its life is usually low, about 30 hours for tungsten carbide. And next is the abrasive particles. So these are the main particles which plays a vital role in this machining processes. And these particles should have high metal removal rate, and the accuracy should be more. And the most common particles normally used are silicon carbide, boron carbide, and aluminum. And depending upon the workpiece, the selection of abrasive particle is made, and it also is selected based on the speed of machining and the machining environment. And next is the abrasive jet machining working. So working process of abrasive jet machining. The basic concept present in abrasive jet machining is nothing but abrasive erosion or metal cutting by high velocity absorptive particle. So, and the working process can be summarized by the following points. So the first is the gas or air is compressed into gas compressor. Here the density and pressure increases. And second is the compressed gas is sent to the filtration unit, where the dust and other particles suspended is removed. And after this, the clean gas is sent to the dryer, and this dryer unit absorbs the moisture from it, and it is used to avoid water or oil contamination of abrasive powder. And now this clean and dry gas is sent to mixing chamber, where the abrasive feeder feed abrasive particle in it, and the abrasive particle is about 50 micron meter grid size. So this high pressurized abrasive carried gas is now sent to the nozzle. So nozzle, where its pressure energy is converted into kinetic energy. Normally the velocity of this abrasive particle leaving the nozzle is about 200 minutes per second. So the standoff distance between workpiece and the nozzle is about 2 mm. So standoff distance between the workpiece and the nozzle should be 2 mm. Now, this high velocity abrasive particles impinges on the workpiece, and these high velocity abrasive particles would remove the material by micro cutting action, as well as the brittle fracture of the working material. So these are all the abrasive jet machining parameters. So the abrasives used normally is aluminum oxide, and it is 10 to 50 micron, and the silicon carbide 25 to 50 micron, glass powder 0.3 to 0.6 mm, and dolomite is 200 grit size. And normally the working medium here is dry air, and gases may be of nitrogen or carbon dioxide. And nozzle material normally is made of tungsten carbide or silicon carbonate, and abrasive materials, aluminum oxide, grit size is 10 to 50, and the orifice diameter is 0.005 to 0.018 inch. And for the silicon carbide, it is 25 to 50 grit size, micro inch, and orifice diameter is 0.008 to 0.018 inch. And for glass beads, the grit size is 2500 micro inch, and the orifice diameter is 0.026 to 0.05 inch. So coming to the application of abrasive jet machining, this is normally used in drilling and cutting or hardened metals. Okay, so it is also used for machining brittle and heat sensitive materials like quartz, glass, mica, ceramic, sapphire, etc. And this is normally used to manufacture electronic devices also, and normally used in deburring small holes and small critical zones in machine parts. And disadvantages of abrasive jet machining. So this also has some disadvantages, because the first disadvantages is of low metal removal rate, and the abrasive particles can embedded into workpiece mostly in the soft metals, and the life of the nozzle is limited, and frequent replacement is required, and you can't reuse the abrasive particles in this process. And this type of machining cannot be used for machining soft and ductile materials. So with this, we come to an end to this video session. So thank you and have a great day.